is part 4 of Python programming. We've kind of been going through, and each part looks at a different topic in programming, and then using the Python programming language as the platform for learning it. You can always go back and watch the first 3 parts, and there's 3 other activity-based programming webinars that kind of go along with this. But part 4 is going to focus on loops. We do have some resources here that you can use. You have Python, the actual Python website for downloading Python and accessing any more information about the actual Python platform. Teach Your Kids to Code is where I get a lot of the foundation codes from. And then the Python standard library is a great resource for learning about functions and getting new functions that you may want to use in your programs. I've aligned the programs that we use in this presentation with the CSTA standards. Looking at variables and program development, those are consistent from the last webinar, but we'll be creating programs using variables, debugging any errors that we make, try to use correct terminology, describe the steps that we're using. Then in addition, from the last presentation, we have some standards in control, looking at programs that use simple loops, sequences, events, loops, and conditions. And those 2 standards come from the first 2 age alignments with the CSTA. We're going to look at 2 programs today. One is called Rosette, and it's going to specifically use an if loop. And then Spiral Family uses a while loop with a condition. And then it also uses an if loop. And we'll kind of look at the difference of the 2 when we write those programs. One of the activities I like to do prior to working with loops is one that I found through code.org. I actually have the link here that you can use from code.org. But it's a simple game that allows you you can take 2 students and pair them up. You give them a set of dice, 3 dice. They roll 1 dice to get their starting value. They roll 3 dice to get their stopping value, and then roll 1 dice to get the interval. And it's sort of a loop. So their starting value will be, for example, the starting value might be at 3. Their stopping value is in 12, and they're going to loop in increments of 4. So they highlight or mark their starting value, their ending value, and then every 4 increments they circle that number, and then they add that total up, and that gives them their score. And then they compare their score to player 2's score to kind of see who wins, and then you can do a best of 2 to 3 rounds. So it kind of shows them how when using numbers in loops, if you have a starting value and ending value and you increment by a different value, what your end value is. And sometimes that can be very hard to visualize. We generally use loops graphically, so it loops in the process of drawing a graphic, so it's very visual. But this is another side of loops where you might be incrementing values, and they need to know what the end value is going to be. So it's a fun game that they can use to learn about loops, and that comes from the code.org curriculum, which is actually a very good curriculum for coding. A couple of things that we're going to do today. We're going to create for loops, which basically loops repeat a set of instructions a certain number of times. We're going to actually give that number of times as a range value, so we can kind of adjust that range depending on what we want the loop to do. The range function is going to generate a list of values to control your for loops, so we're going to actually use that function there. I'll show you how to create an empty list and add to that list using the append function. So for example, you might have an empty shopping list and you want to add items to that list as you type them in. The append function will do that for you. We're going to use a while loop to repeat until a condition is true, or while a condition is true, or until the condition is false. And then we'll look at how each loop works within the Python coding language. I do provide a link to both of these programs where you can kind of copy and paste these into your own Python. And then you won't have to do any kind of adjustments. All you got to do is copy and paste them into Python, and you can run them and see how they work and make adjustments. So I have links to both of that programs. They link to my drive, and you can get access to those from there. So to lower this, we'll look at Rosette first. This program is using a loop. It's using a for loop to graphically. It's a graphic-based program. It's going to draw out. In this case, it's going to draw out 50 loops, and it kind of models or looks like a rosette when it's drawn. So the first thing we got to do is import Turtle, which is our graphics program. We set up our pen that we're going to be used for drawing. It comes from the Turtle library, and it's a pen or a class. And I set it equal to a variable. So we're using a variable here called pen. And anywhere that we want to use this pen, we can just use the variable pen and not have to use turtle.pen. So it's a little easier way to do that. We're going to increase the pen speed. So this speed function actually modifies the pen's generic attributes. So the pen class, right, creates a generic pen. It's a single pixel width. It has a basic speed. It's black. Its color is black. And then you can modify the attributes of that pen through different functions. So we're taking the pen and we're modifying its speed. That's what we're doing right here. And the 0 is, it's not a numerical value as far as speed, so 100 isn't the highest and 0 is the lowest. 0 just says that we don't want to see any of the animations while it draws, so it's a faster way of getting the graphics done. We're using a for loop and using a variable x to move through our loop, or to repeat something a certain number of times. And our range function is going to give us, in using the value 50, it creates a loop that's going to do whatever I tell it to do 50 times. It does not mean it's looping to the number 50. It means it's doing it 50 times. So it's actually going to start at 0 and go through 49. And if 49 plus that 0 is actually 50, 50 times going through the loop. That's important to remember. If I wanted the very last length in my drawing per se to be 50 pixels long, then I need to adjust my range to make sure that I get that last value is 50. So again, in the case of this loop, our first value is 0 and our last value is 49. We're not using x anywhere in our actual loop, but that would be important if we actually used x inside of our loop, because it's going to start at 0 and then x's next value is 1, next value is 2, ending value is 49. So that's something that's important to remember when you're using a for loop and you're using a variable to move through that range. So this case, I'm going to take the pen and I'm going to move it in a circle. This is the diameter of the circle in pixels. And then I'm going to take my pen and move it to the left, or turn it to the left 91 degrees. So both of these functions, again, are modifying what the pen does, or these are functions that are working with the pen. So take the pen, draw a circle 100 pixels in diameter. Take the pen, turn it to the left 91 degrees. Do that again. Pen, circle, pen, left. And it's going to continue to do that 50 times, which is the number of times that we have our loop running. So This loop is going to, there's no condition for this loop to end except for the number of times that we want the loop to repeat, which is 50. So the only way to cancel this program once it starts running would be to quit the program. We'll look at a while loop in our next program that has a condition that will allow us to end the loop earlier or later, depending on the condition. So I'll run this one real quick and we'll see what it does. So I'm going to close it and run it again. If you notice, it draws the first circle, it turns 91 degrees, draws the next circle, and it does that 50 times. So if you were to count the circles there, you should have 50. I can modify my range coming back in here. This is a great thing for students because they very quickly pick up on the things that they can modify and change. So if I increase my range to 100, you get significantly more circles and they begin to overlap. So if you were to slow it down and watch it piece by piece, you're going to see that the pen draws a circle, it turns left, and it goes back in the range. So and it repeats this continuously without stopping. There's no condition for stopping it. So if I increase it, so I have an opportunity to cancel it. The only way to really cancel it is just to close it. So that loop is going to, that for loop is going to run until that condition is met. The other thing they can adjust is the diameter of the circle, and they can also adjust the degrees to which the pen turns. Pretty simple there. They very quickly decide that they may want to change the background color, which is as simple as taking the turtle window, which is the graphic window that opens. So I'm taking that turtle graphics window. I'm going to modify its background color, which is BG color. You can use HTML color codes in here, or you can just use simple colors. Let's see if gray. I never know if it's spelled the English way or the. So I quickly modifies the background color. And then if you want to, you can also very quickly take the pen and modify the pen's color, right? Modifying its generic attribute of black, and then running it again, and you get sort of the white on the gray. So these are very simple things that students can adjust and modify and see a very quick, very immediate response to what they're doing. And I'm just going to drop this back down. So they can adjust the range, they can adjust the diameter of the circle, they can adjust the degrees to which the pen turns, they can adjust the background color or add a background color, and they can adjust the pen's actual color. And then they can also adjust the pen speed. I'll run that one more time. So a very visual way to see a loop in action, and it's actually a great place to start. Teaching loops where you're incrementing numerical values, kind of like the activity-based programming. Even though that's a great activity to show kids how that works, I definitely would start teaching loops by showing them visually what a loop actually does. It's just a great visual way for them to learn and make adjustments and see how those adjustments affect the loop. So that's Rosette. Let's see, close this real quick. So the next program that we have here is called Spiral Family, and what this program does is it uses two loops, a while loop and a for loop. And the while loop in this case has a condition that needs to be true or false in order for it to move past the while loop. In that case, If you look down here, our while loop has a variable name, and when name is not equal to blank, right, it's going to take some input and add that input to our list. So if I go back up to the top, it's a graphics program again. So I import turtle. I set up my pen. My variable pen is equal to my pen class in the turtle library. I take the turtle window and I adjust its background color to black. And then I set up a list called colors. And one of the ways we recognize that it's a list is that we're using a bracket here. One, it has multiple items inside of it. It's a variable equal to multiple things. But we also use the brackets on each end to indicate that this is a list, right? So in general, variables are equal to one thing unless you put them in a list, and then you tell the program how to move through that list or which ones you want to grab in that list. In this case, we have a series of colors. Looks like 10 colors that we have here. The next thing right below it is a list. It's also a list, but it's empty. And this list is called family because we don't know what the end user, we don't know the family names or the number of people in their family. We can't start with anything inside this list. It has to be empty and allow them to populate that list with their own family names. So this list starts empty, and this is where the append function is going to come in just a second. So the big difference between these two lists is with colors, we provide the colors that can be used. Inside the list, family list, it's empty because we don't know those family members' names or whatever they want to type in response to the prompt, which they're going to get next. You could have an empty colors list and also prompt for colors, assuming they spell the names correctly and they're recognizable, then you could populate a list with colors also. This is just a little bit easier. So next we have a variable called name, and it's equal to a text input. And what's different about this text input is it pops up inside the turtle window. So when I go to run this program, the graphics window is going to pop up, and then a small box is going to pop up, and it's going to have a title in the box, my family, and then it's going to have a prompt, enter a name, or just hit enter to end. So they have two options. They either type in a name, in this case a family member's name, or they're just going to hit enter. And that's going to be important when we come down to our while loop. So when we get down to our while loop, it's using the name variable as its condition. So while name is not equal to blank, and the only way that name is equal to blank is when they just hit enter. So if they just hit enter, name will be equal to blank, and the program is going to go past the while loop and get to this for loop. So while name is not equal to blank, we assume that they have typed something in, or else it would be blank. And what happens here is it takes whatever they typed, it takes the family list, and it appends to that list whatever they typed in, whatever the variable name is equal to. So it pops up, you type, Pancake, which is the name of our cat. It takes the name Pancake, it sets it equal to name. It comes into the while loop, and since name is not equal to blank, because right now name is equal to Pancake, it takes my family list and it adds to my list the variable name, right, which right now is equal to Pancake. And it adds Pancake into my list. It then, since it's inside the while loop, it does the next command in the while loop, which is the exact same question again. We're going to take the variable name and we're going to ask, do you want to enter a name or just hit enter to end? If they type in another name, in my case, Melissa, then it comes back up to the while loop. Name is not equal to blank. It's now equal to Melissa. So it's going to take the family list. It's going to append to that list whatever the value of name is, which is Melissa, and it's going to add it to my list. And you can do that over and over until they hit enter. And once they hit enter, this condition is no longer true and it moves past the while loop. So the good thing about this while loop is that we can stay inside this loop as long as we want, depending on the number of names that we want to enter as our family members. So it's a neat little condition that you can use. So one other thing about this is it needs to stay within the 10 colors, but that's just something minor. If they wanted to do a whole lot more names, you need to add colors for those names. So I have 3 members in my family, at least my direct family. So my list would have 3 names. Well, and if you include the cat, right? So we can include myself and the cat and my wife and daughter, and we'd have 4 names in our list. So once this condition is false, it's going to jump down to our for loop. And our for loop is different from our while loop because it doesn't have a condition to end except for the number of times I tell it to repeat. And in this case, I'm telling it to repeat 100 times. And once it's done doing that 100 times, then our for loop would end. And if we had any commands down here, it would move to those commands. Inside of our for loop, we're taking the pen and we're modifying the pen's color by going into the list of colors, taking the value of X and modding it using the length of the family. So this just becomes important because we don't know the number of names in that list. And in order to pick a color from that list, and we talked about this in a previous webinar, we need to divide X by the number of items in the list. And that allows us to choose colors in sequential order. Since the length of that list is going to be different depending on the end user, I just can't put a number in here. I have to make this number equal to the number of items in the family list. Again, since I don't know that, I have to use this length function, determine the length of the family list, and then use that value here. I then pick the pen up, I move the pen forward, and I put the pen back down. Just like if you were drawing a picture on paper and you didn't want to have the joining line that you might, if you were to move your pencil on your paper, you pick your pencil up so you don't have that line drawn. That's all we're doing there. We're using a function called write, which allows us to write on the Turtle Graphics window. We're adjusting, again, using the length of the list. We're adjusting the font size, and the font's condition. In this case, it's going to be bold. And then we take the pen and we turn it left by taking the degrees of a circle and the length of the family list and adding 2 to it. So it allows it sort of the names to start small and their font increases. This is what we're doing here. The font increases as the names spiral away from the center of the circle. So part of this is just seeing it. So I'm going to run it real quick. Cool thing here now is our window that has our text here, my family, and then it has the prompt. I like this because it pops up on the Turtle Graphics window. I'm going to add the members of my family, so I type it and hit OK. So if you're going back to that while loop, let me just move these over here. In the case of the while loop, when I typed in Melissa, name was not equal to blank, it was equal to Melissa. So it took Melissa's name and it added it to the family list and then asked me again if I want to enter a name. That's where we're at right here. So I'm going to type in, I typed in my wife first, which is really important. And then my daughter's name, so I'm going to hit OK. So it goes back through and it checks, was name equal to blank? No, it was not. It was equal to Morgan, so it adds it to the list, and then it asks the question again. I'm going to put myself last in the family here. So I add the cat, and then I add me. That's probably really the ranking, the family ranking there. And so now what I'm going to do is when I hit OK, name is going to be equal to blank. And since name is equal to blank, this condition is no longer true. So it's going to move past our while loop and go into the for loop, which actually draws out the name. So when I hit OK here, the drawing sequence begins, and it spirals out the names. It's only using 4 of the 10 colors because I only have 4 members in my family list. If I wanted to move through all 10 of those colors, I would have to include more names. And that's just how the using mod in order to choose the colors in a list works. So I guess I end up being green. So a couple of things you can adjust here in this program. You can adjust the background color. They can adjust the actual colors that are used. They can adjust the text that pops up. You could say my favorite cars and enter car name. So it gives them some, and you'd have to change those down here too, right? So everything would have to change. I could do that real quick, I think. Let's see. Right, and then when you run it again, right, it prompts my favorite cars and enter a car name. My all-time favorite cars are cars that I can't have. Sorry, and then last but not least, the Volkswagen, people's car here. And then I hit OK, and it's going to spiral. In this case, I only used 3, so I don't actually get the green color, because if you go back, it was the 4th color in our list, so it's going red, yellow, blue, red, yellow, blue, red, yellow, blue. If you want to have certain colors always, then you need to move them to the front of your list, or maybe have some kind of random way of choosing colors from your list. So if we went back to the things that we were wanting to accomplish today, it was writing a program. It was using while loops and for loops, and also using the append function, which allows us to add values into an empty list. And I'm going to, probably next semester, I'm going to modify this program to show how to create a simple list program for listing things that we may need: grocery list, games that we like, cars that we like, hobbies that we have, or homework that we need to do, and show them how to create that list, add to that list, and then remove items from that list. So, but I have found that at the age group that I teach, anything that you can do graphically, if you can represent programming graphically, it's easier to learn. It's easier, obviously, to visualize and see, and they generally see the outcomes. It's just more obvious, the changes that they're making, what is happening on the end user side. So I tend to stick to programs that function graphically, but they're not always the ones I do. So we'll go back to our presentation here. Just to kind of go back, we looked at creating for loops to repeat a set of instructions a certain number of times. And we set that number of times using our range function, which was our second thing that we wanted to do. We created empty lists, and we added items to that list by using an append function. We created a while loop that repeated until a condition, while a condition is true or until the condition is false. And in our program, the condition was if the variable was equal to something or not. And then we looked at how loops worked. And again, these programs, the codes for these programs are linked here. If you just click on the link, it'll bring you to a version that you can copy and paste it directly into Python. So that's a great way to do that. And then last, we met sort of the new standards that we were wanting to do here. We looked at simple loops and conditionals, right? So the simple loop would be the for loop. and then we looked at while loops that used a condition in order to end. So that's it for now. Part 5, I think, is Thursday, and then we may have 2 more. So I hope that you're learning something from the webinars. If you have any questions, you can always reach out to me through EdWeb, or you can reach me directly through my school email address, and I'll be glad to help provide all of the programs that I use and all of the activities that I use when teaching programming. And that to me is it's a lot of fun when you can connect the program to an actual game or activity that you use in the classroom. So thanks again for listening, and I look forward to seeing y'all again. Thanks.